Okay, so now that I've covered the destruction toolset, I would like to cover probably the second most important one is the optimization tabs. I use this at the end of a lot of network trees. But let's get started with this then. So the idea for this is really to optimize a really heavy geometry. And you'll find that a lot with environments, or if you have something like just huge stuff. So real quick, I'm going to go ahead and make just some really heavy environment. All right, so now that I have this terrain, you can see that it is 6,250,000 points. So it's pretty heavy. We can go heavier for sure, but it will be slower. So I wanted this tutorial to at least go somewhat smoothly without too many pauses in between. So this is still a pretty dense mesh. We can definitely get this a lot lower than it is. Okay, so we're also going to need a camera. I dropped down this camera one, and let's say our shot some sort of character on top of this hill or something like that. Let me put a test geometry Tommy up there. All right, so that is our reference. I'm gonna delete these distant lights. I'll create some new ones real quick. All right, so I got two nice little distant lights that kind of help illuminate some of the scene if I want to use visual lighting. However, right now, I think I'm just gonna go with a flat lighting. And we have this terrain. So if we right click or hit tab and go into the easy tab, and then go down to optimization, you'll see easy camera crop, easy optimize, easy poly reduce by camera, and easy poly reduce lock edges. This one is kind of just a paintable poly reduce, and these two, the easy camera crop and the easy poly reduce by camera, are actually included in the easy optimize. So really, unless you're working on specific scenarios, you're not going to use these two that much. You will genuinely use the easy optimize at the end of your network tree for heavy geometry. Just go ahead and plug in the easy optimize, and the first thing we have to do is we'll see this camera option. We got to go find our camera, and then once we click it, it'll start doing its thing. It might take a minute just because we're dealing with heavy geometry. Okay, so if I hop out of this now, immediately it crops out anything that's not in focus of the camera. So if it's outside of the camera padding, then it's done. It's killed. You won't notice any difference between the two of these. In some cases, this takes out a large chunk, and in other cases, if your whole scene is in the shot, it's not going to do nearly as much. So this brings us down to 3 million. We were at 6 million points. Now we're at 3 million. And so the easy optimize node works with three kind of processes. There is the camera crop, which is the first of the three. Pop out a window real quick just so you can see this a little better. What are you doing? All right, so camera crop is the first one, which is going to basically just crop out anything that's not in that camera's lens. The padding is how far it's going to allow it to push it. So the lower this goes, the more geometry you're going to kill off, but you might run into situations where you get cut polys around the edges here. So if I bring this like really down low, like if I go 0 on the padding, you'll probably see some very light holes here. Yeah, you'll see stuff like this if you go down too low on the camera padding. So by default, it's set to 0.2. That is pretty safe. 0.2 is a pretty safe bet. You can definitely go lower than that usually, but just for defaults, I leave that on there so it's easy to just throw this thing on. So we'll go to 0.1. So that is the first step. After that, we have this poly reduce by visibility. And if I visualize this, what this is doing is this is taking the camera and it's casting this whole mesh at the camera, and then it's casting it back, and it's saying, okay, what points have a clear path to the camera? And if you have a clear path to the camera, as in if you can go from your position to where the camera is without intersecting anything, then that gets an attribute value of 1, and we know that that's something that we should keep at a higher resolution, and we shouldn't poly reduce. However, all these black spots are spots that they tried to launch at the camera. They launched at the camera, and then on their way back, they ran into this mesh before they could get back to their position they came from. And so those are going to output values of 0. That's going to tell the poly reduce that, okay, these are areas you should poly reduce because we can't actually see them. They're out of our view. So it wouldn't hurt anything to poly reduce these areas. If I do percent to keep, I just take this down to 25. Might take a second. Okay. So now that that has finished, you can go ahead and you'll see that areas that are in the view So if we visualize this, areas that are able to be like actually seen by the camera, they won't get polyreduced much, at least. And they might still get some polyreduction, but they won't really get polyreduced. And you can actually even see, just as a general kind of visualizer, you can't see any of the black attributes in the actual camera view. You might be able to see a little bit of them creeping out along the edges, but they're there. You're just not able to see it because obviously those are places that you can't see. So bringing it down 25% took us down to 416,000 polygons, which is already a massive jump from the 6 million. And if I go into a flat shaded view, I'll go back and forth between these. So that's the original. This is the optimized PolyReduce version. So this virtually looks no different, and it's about, let's see, it's about 12 times lighter. I might be wrong on my math there. Regardless, a lot lighter. You can keep bringing this down. Also, the nice thing about PolyReduce is once you bring it down to a value, so once you bring it down to percent to keep, say 10, it doesn't have to recalculate if you go back up. And then on the last tab is the PolyReduce by distance. And what this is going to do is this is going to take your camera, and then it's going to resort the points real quick based off which point is closest to the camera. And then it's going to go through every point and then figure out which point is the farthest away from the camera, and that's going to be the last point in the chain. So basically all I'm doing with these sorted points is I'm saying the closest value is going to be 0, the farthest away value is going to be 1, and we're going to interpolate between those. So it doesn't matter what actual distance this is based off. This isn't based off of actual distance. This is based off of relative distance to the camera. And it's always going to be a 0 to 1, no matter how many points you have, no matter what you plug into this thing. It should always work just based off closest to farthest. And then I'm using that attribute to drive another PolyReduce. And in here, we can play with this ramp. Again, a value of 1 means that it's going to keep the geometry. A value of 0 means that it's going to reduce it. So you can play with this ramp to kind of visualize where you actually want the reduction to happen. Maybe actually even a little closer, because I don't think we really need much of that detail. So now I'll go 25 on this guy. And now we're down to 102,000 primitives and 52,000 points. I'm just going to go ahead and reset this to the default ramp. So the influence settings basically works as like a scale or like an intensity multiplier of how intense the polyreduction is based on the attribute that we're creating. So in this example, the attribute we're creating goes from 0 to 1, from closest to the camera to farthest away from the camera. You can think of this like a multiplier on that number. So cranking it up is going to make the difference between the non-polyreduced areas and the polyreduced areas greater. Bringing this up too high will cause some issues where basically the back of this thing is going to almost completely disappear, but we will keep the influence here up at the front really well. So it's kind of a just a little bit of a tweaking game. The default values are pretty good usually, but you can definitely do better yourself. Let's see. I'm okay with 32,000. So we took this thing from, turn off the visualize for this. We took this thing from 6 million points to 32,000 points. And there is definitely going to be some difference, but pretty good, honestly. And we can bring this up, maybe see how close we can get it. So now that's 76,000 versus 6 million. And that's going to be a lot easier on our render and just file space and everything. So if I cache this, there's actually, I forgot there's a built-in one in here. So if I take this easy optimize and I go, okay, I'll save this current frame, save disk, and I just load it, you can actually see that this easy optimize is only 5.93 megabytes. Whereas the original geometry was 452 megabytes. And that is a big deal when, I mean, 6 million is definitely not even close to the heaviest mesh I've worked with before. So when you're capping out your GPU and your render memory at say 8 gigabytes to 12 gigabytes, and you're spending a whole half of a gigabyte on just the mesh geometry, And this thing doesn't even have attributes. This is just point, position, and normals. So when you're spending that much memory just dedicating to these meshes, you're gonna kind of clamp down on your GPU usage, which in turn can slow down your render a ton if you start going out of core. But yeah, so that is the gist of the easy optimize. I'll show you some of the advanced features here though real quick. So the advanced features here, one really nice thing is that there's two outputs actually. The default output is going to be your optimized geometry. However, the second output comes from this camera crop, the very first step of the process. And inside the camera, it's going to look like a mess. But what it is it's spitting out the volume that it uses to cut the geometry with. And you can use this for a lot of other stuff. So then you got a slew of advanced settings over here. I'll just go through these. First, actually, I think it makes more sense. It's everything that you would find on your actual PolyReduce node in these settings. And then remove unused points is basically just gonna blast out any points that don't have connections to anything, so they don't show up in Redshift as like particles or something. It's an attribute delete if you want to delete any attributes in here. And then it's going to compute the normals. And then there's actually a UV generation in here. You can just UV unwrap it if you want. And I'm going to visualize the UV here. You can do a UV texture. I do believe that I actually have to turn off this. I didn't cache this. File cache comes last. So if you're loading from disk and you're trying to edit some of this stuff, it's not going to work. So we have a UV unwrap, which is going to allow us to unwrap the UVs if that's what we want to do. We have a UV texture, which will just basically project the UVs directly down. Then we have a UV from camera perspective. And this one's fun because it's basically going to ray on some UVs that will line up perfectly for the camera view, but they won't line up if you go anywhere else. So be careful with that one. Once we get into the animated camera settings, I'll show you the lock to frame is basically just saying that instead of animating these UVs with the camera, it's just going to lock the UVs it generates only from one frame. Then you can choose that frame here. And then lastly, you have this UV project. And the UV project is also nice because it's set up to kind of take care of the scale of everything for you. It basically matches the scale to the max size of whatever you have set up in here and then projects based on that, so you don't get any weird situations where you have to scale something up a ton to get the projection to work right. So yeah, so that is the gist of these UV controls, and I'll go ahead and I'll show you the animation now. Now, a big thing for me was these techniques I've been aware of for quite a while, but they don't really work when your camera animates. So I'm just gonna disable this for right now and I'll visualize the heavy geometry. And so like if I was to take this camera and add some keyframes on frame 1, and I'll just put this to frame, let's go 80. And then at frame 40, maybe I come in and then last frame, and then I'll just go ahead and I'll make all of these splines just to make it smooth. Okay, so that's our animation. If we were to use this setup here, I'm actually going to go ahead and just load from disk. Okay, so now you'll see that we get issues where we start to see some of the stuff that we cropped out. And I'm actually going to make this more drastic so we can maybe see some more stuff. Okay, so with this camera now animated, I'm going to turn off the, well, before I do anything, I'm going to disable both of these so that it doesn't calc all of it at once. And I'm going to turn off the load from disk. Let's go back to the main tab. And for animated cameras, I would probably put this up, the camera padding up to 0.2. So we have this camera animation tab, and by default, it's disabled and the camera frame is set to 1. If we enable it, I'll explain what this is doing in a second, but let's let this cook. All right, so that took about 50 seconds for it to actually finish up. Now, what it did, I'm going to allow editing contents so I can jump into this. So it takes the easy camera crop, and maybe I jump into this too. It takes this geometry over here, which is the bounding box of the whole mesh, and it says this is everywhere that the volume even can be. And then it takes the volume generated by the camera, and it uses a volume mix to say, okay, copy the value from the camera onto whatever values in this box already exist. So we end up with this volume that's not kind of overdoing anything. It's not adding all this stuff up here. It's just keeping itself where it needs to be, and it's optimized. So then we run that into a solver, and all I'm doing is merging this and the last frame together, and then I am volume merging them and then running a resample to make sure the volume size doesn't get too big. After that, I just run it into a time shift, and we're gonna steal the last frame of this animation. So it's gonna be frame 80. And that's what we're going to have it locked to, because that is going to represent everywhere the camera is ever going to look. If each frame is generating a volume that represents where the camera is looking, and each frame I add the previous frame on top of it, you're going to end up with a volume that represents everywhere the camera will ever look. And if I have that, then I can blast out everything else. So that way, even when the camera moves, you're not getting point counts that jump around and change values, which can really mess with displacement, and it can mess with UVs. It can mess with a ton of stuff. With this workflow, it's going to take everything from this last frame, and it's going to use that as a group to basically say, okay, this is everything that we never see. No matter where the camera goes, we don't see any of those points. So we can blast that out and have confidence that we're not going to have some jumping point counts, and this isn't going to have to recook every frame. It's going to take longer on the first frame, but after that, you're going to have a mesh that throughout the entire animation, we're keeping everything that ever gets seen. Now, the PolyReduce visibility works the same way. And like I showed you before, it's going to take a second to figure this out, but like I showed you before, when the values were black on any area that wasn't viewed by the camera, and they were white on any area that had been viewed by the camera, all I'm doing for that is I'm running that into a solver and then that into a point VOP and saying, okay, keep the values from this frame, and then I add in the maximum from the frame before it. So I end up basically cultivating the values that we can see in frame over the entire frame range. Now this one is definitely the heaviest of the optimization kind of things to run. It'll save you time in the long run, and you just kind of have to let it run once. Yeah, so this is 17 out of 80. It's taking a minute. Now the thing about this is that it runs before the actual poly reduction. So we're just getting the attribute that tells the poly reduction how much to reduce by. So after we do this one calculation, we can poly reduce the weight as much as we want. We can say reduce by 20%, 15%, 10%. We can change all that stuff. It's not going to recache all of this. It's going to keep that information and then run the poly reduction on top of it. So I'm going to pause this while this does its thing. All right, so it just finished. So I'm going to hop up the chain back to the main level. And if I enable this, you should be able to see the poly reduction now. That wire shaded. And if we visualize this, so that is the visualization of it. And basically, it's doing this over every frame. So if I look through the camera, you're not going to see these black points even though the camera moves. So we have this value that basically determines everything that will never be actually in the shot. So we can use that to kind of reduce. And you can also change the camera view influence. It's going to have to recook the percent to keep, but you're not recooking that attribute that we generate over the frame range. And it's the same workflow for the poly reduce distance as well. So you can see very clearly now that I cranked up this camera view influence, how this is actually kind of affecting these areas. And if I just crank this down, maybe to percent to keep somewhere in here, so I don't want it to get those big edges because those could cause issues. So that is now 726,000 points, and it looks virtually the same. Let's see if eventually, if we bring this down too low and the camera view influence too high, then we will start to see some of these areas, and that's what I'm trying to avoid. For the moment, I don't think we can. I think we're in the clear. We've got that down to 412,000. I can enable the distance. I can do the same thing. Let's see, so that leaves us with 217,000 points, and the mesh will not move. So you don't have to worry about a jittering point count. Even though the camera is animated and moving, we're only producing the stuff that never actually sees the camera anyways. So that's great. I'm going to go ahead and pop this into a single view and show you the last optimization tool in here. Go to easy optimization and I do easy PolyReduce lock edges. This is essentially a paintable poly reduction. And so I can hit enter and I'm going to paint where I want to keep. And I'm going to pause the poly reduction here while I do this, so it's something that I can actually do and it doesn't have to recalculate every time I drop something down. I just want to keep more of the ridges, I think. Okay, and I'm going to enable the blur, and I'll just blur this out a little bit. And now I don't care about visualizing the weight anymore, so I'm going to hit escape to get out of the handle view, and I'll just turn this down to like 25. Let's see what, or actually, no, I need to, it's my bad. I need to go to the PolyReduce tab. That's just for the paint, and I'll take this down, let's see, 20. So you can see now if I do enable this, it's only really reducing in the areas that we didn't paint. And this paint weight is essentially the same thing as this fall off influence back here. And this is something that you can have already painted and you can change this value. It doesn't matter. And let's see what we got here. So now we're down to 40,000 from 217,000 from 6 million. So that is the gist of these nodes. Easy camera crop is just the first tab in this easy optimize. And the easy poly reduce by camera is just the second tab. The third tab is actually exclusive to the easy optimize node. I didn't build that into any of the other ones. So really this is the main one you'll be using. I did, however, just include, I made the other ones first. So, and then I kind of bundled them together. There is one last thing I think I'm going to show. So if I go back into the camera and I go over to this advanced tab and I do the UV generate and I do UV project from camera, if I turn off this lock to frame, you'll see that the UVs project onto the mesh each frame. So the UVs actually move with the camera. And this might be what you want. I don't know what you might use this for, but by default, it's set to lock to frame, and it's going to lock to a frame in your sequence. So it's using frame 1 as the locked frame. And you can actually get away with quite a bit here, usually. But if you don't like frame 1, you can cycle this through, and it'll lock to whatever that frame is. Okay, so I think that sums up the optimization parts of this course, and pretty smooth way to go from 6 million to 217,000. So thanks for watching. I hope this shed some light on these tools, and we'll keep going through the pack here in the next few videos.